Hello everyone, this is Luke. I'm the author of CollectionKit. Today I'm going to go through a tutorial of using CollectionKit to implement a SearchUI. It's going to be very simple and it's not scripted in any way. I'm just going to do some live coding and the result will be similar to something like this, where we have a list of image cells displayed within a collection view, and we also implement a search box at the top that allows us to live update the content within the collection view. And here for this example, I'm going to use the Unsplash API, which allows us to fetch a list of images from a keyword. So without further ado, let's get right into it. To start, let's create a new Xcode project. We will just be using the single view app template. Give it a name. I'll just call it Unsplash Search for now. And then save it to a folder location. Next, we won't be using this main.storyboard to create our UI. We will just be doing that programmatically. So don't worry about the main.storyboard and app delegate too much. We will first need to install our dependencies. So let's go to the folder that we just created for this project, Unsplash Search. And then we have to create this pod file, which lists all of our dependencies for this project. And if you have been using CollectionKit before, you will know that once you list out all the dependencies here, CollectionKit will help you create a new workspace which contains all of these dependencies. Here, of course, we will be pulling CollectionKit. We will also be using pin remote image as our image fetching library, and we also be using Alamofire to send the search request to Unsplash. Notice here we are using the Alamofire 5 branch. It has some neat shorthands for the new Swift feature called Codable, and you will see later on why we chose the Alamofire 5, and it will make the fetch request a lot easier. So save this pod file and then go back to your terminal and type in pod install. If you are unfamiliar with CollectionKit, please go Google for it and search for a tutorial that helps you understand CollectionKit more. Here I won't go into too much detail about it. So once the pod install is done, let's close this Xcode project that we just created and open up the workspace that the CollectionKit created for us. We will still have our app delegate and view controller. So let's first run this to see if it builds and see if it fetched all of our dependencies. Yeah, my laptop is pretty slow. I will just do some coding right now while it's compiling. So of course we need to import our CollectionKit as our first dependency. We will also be using Alamofire, so let's import that as well. For pin remote image, it's not needed right now. I won't worry about it too much right now. So let's just start with these two. Okay, it compiled fine, and right now it's just a empty view, empty white background. And let's go into how to implement that SearchUI that we talked about in the beginning. First, of course, you will need a collection view. Here, let's just initialize a new collection view and then add it to our root view. We will also need to lay out the collection view to take up the full width and height of the screen. So inside view layout subview, we can say collection view.frame equals view.bounds. This way, the collection view will be the same size of our root view, so it will take up the entire screen. Next, we have to tell collection view what data we need to display. But right now, we don't have any data. So let's implement a search method that fetches our images from Unsplash. So in this search method, I'll use alamofire dot request. We'll be using the alamofire library to do a HTTP GET request. If you go to the Unsplash documentation, you will see that there is this search photos API, which if you give it a query text, it will show you a list of image metadata related to the specific query. So we will be using this dataset to fill out our collection view. Let's just copy the URL here and then paste it right in here. We probably don't need the page parameter, but we do need the query parameter and give it our text to it. Let's also take another look at the response that we get from Unsplash. In the top level, there's this results array, which has a list of image metadata. And we see that each of these metadata has an ID with colors, description, users, and URLs to download the images. In Swift 4, there's a new codable protocol, which we can use in conjunction with alamofire to make a simple structured API request. Let's make a new struct that represents our image metadata from Unsplash. We need to make this codable so that alamofire will be able to parse the JSON file and fill in all the data inside this image metadata. For each image metadata, there's an ID. There's also a user object, which has all the user information, meta user. What am I typing? Metadata. Let's also define the user metadata right now. It also needs to be codable, and right now the only thing we care is the user's name. We also need to get the URL to download the image. If we take a look at the response that we get from Unsplash, what we really need is this regular download URL that is contained within URL.regular. So let's define another struct that hosts all the URLs. URL list. And let's define it here also as codable, and we only need the regular URL here. So that's our image metadata. With alamofire 5, we can actually use a new response JSON decodable API, which alamofire will help us parse the response into a specific data structure in Swift. So in our response handler, let's give it a type of data response. And then the response type that we actually get from this is image metadata. Oh, I'm sorry. The response that we get is not a single image metadata. It's actually an array of image metadata contained inside this results key. So let's define another struct. Let's define it as unsplash API response. Make it codable as well. And then it has this results array, which hosts all the image metadata. So the response we get from this URL, it's actually a unsplash API response. There's another thing to watch out for with this API request. We will also need to provide a client ID in order to actually fetch the request. You will have to go to Unsplash's developer page and register the application. Here, I'm just going to provide my own client ID. Feel free to use this in your project as well. It's currently limited to 50 requests per hour. That should be sufficient for this example. Inside the response handler, we will just print out the response that we get for now. If you take a look at response.value, you will see that Alamofire has already parsed the JSON response into a struct that we defined ourselves. So response.value.results actually holds the array of image metadata. Let's just do a search inside view.load to test out if this API actually works. Let's run it and see if we get a console printout. You can see that we get back an array. The array starts here. And each of these arrays is already an image metadata with the ID, the user, and also the URLs. Pretty neat, isn't it? Okay, now let's construct the collection view. We will assign a new provider inside the view.load function. We'll be using the basic provider. We'll also need a data source. Here, let's use array data source with data type of image metadata. We also need to give basic provider a view source for it to construct. Let's just use the collection view source, closure view source, and give it a view updater. Let's just use UI image view for now. And the data type will be image metadata. So for each of the image view, we will be using pin remote image library to fetch the image from the URL that we get from image metadata. So we use this pin set image API from pin remote image. Let's construct a URL from the URL that we get from image metadata, urls.regular, and that's it. We'll also need to provide a size source. Size source tells the basic provider how big you want each cell to be. The parameter you get is the index, the data, which will be the image metadata, and also a collection size. And you have to return a CG size to within this function. So here, we will just be returning a CG size with width of collection size.width and height of maybe 240. So basically, the cell will fill up the horizontal space, but it will be 240 pixels high. Also, in the response handler for our search function, we'll update self.dataSource.data to be the data that we get from the response. This way, once the API request is made, our data source data will be updated to be the response that we get. And then the collection view will automatically update itself. Let's run this example to see if it really happens. Voila. So we get a list of images fetched from the API request that was made here. Though right now it doesn't look that beautiful. You get the ideas of how to use an RESTful API to update the content within a collection view. So to make this a little bit more pretty, let's construct a new view called image cell. UI view. Inside its init, we will add a we'll add the image view as its subview. Let's also add a label, UI label. Inside layout subviews, let's have the image views frame to be with the height of maybe 200, and the label frame to be starting with the origin of 10 to 10, and the width of bounce.width minus 20, and height of 20. You will see the effect of this later on. Let's also make this a little bit more fancy. Let's give it a rounded corner. So layer.corner radius equals 4. Let's also give it a shadow. Layer.shadow color equals .black. UI color.black.cg color. Layer.shadow width, shadow radius to be maybe 14. Layer.shadow offset to be maybe 14 as well. Layer.shadow opacity to be 0.2, I guess. And then let's also write a function that populates the image metadata to the view. So image view .pin set image from URL and URL string image metadata dot URLs dot regular. Also label.text equals image metadata dot user dot name. Maybe let's do it more fancy. Photos by the user. Looks nicer this way. So inside the provider that we just made, let's change the view type to be our custom image cell. Instead of setting the image directly, let's just do view.populate with the image metadata that we receive. This way, each image cell will populate its own data, and it will also display a label that shows the user's name. Let's run this example and see. You see now each cell has an image, and it also has a text that displays the user's name. It's looking pretty good. Next, let's add some spacing between each cells. I noticed that right now the cells there isn't any spacing between them, so it looks a little bit off. So let's add a spacing of 20 between each cells. Let's also add a content inset to the collection view so that each cell is not sticking to the edge. Let's reserve some space at the top for our search bar later on. And let's give 20 pixels content inset to the other edge. I also noticed that I didn't give a background color to this image cell, so the shadows appears above the label. If we give it a background color, the shadow will appear outside of the image cell, so it will appear below the label, which will make it look better. Let's run this example. Well done. You will see that it's looking pretty great now. Looks pretty similar to our target project. Your scrolling looks nice. You just have to add a search bar at the top to allow user to do their own search instead of always displaying photos for Toronto. No, here should be photo by, not photos by. So to do that, let's add a text field. Search field equals UI text field. For the search field, let's do some configurations. Search field.delegate should be assigned to the view controller. So the view controller has to conform to UI text field delegate. And if the text field ends editing, we will do a search. What's the text field's current text? Another thing is when user hits enter or hits return in the keyboard, the text field will call text field should end editing. Sorry, it should be should text field should return. And inside this, let's just call text field resign first responder and return true, so that the text field will be deselected whenever the user hits return. And once the text field got deselected, it will do a search. And then let's also add it to our view add subview search field. The only other thing we have to do is to lay out the search field here. Search field dot frame. So frame equals CG React X 20 Y of, I'm not sure, 100 maybe, was of bounds view dot bounds dot width minus 40, height of 50 maybe. Let's see how that looks. Let's start. So I didn't give the search field any background color, so it's probably somewhere here. Yeah. Let's just test out to see if it can do any searches for us. So let's try C, return. Nice. You see the photos all got updated. Okay, now let's go back and add a search field background. I want to animate this background view alongside the search field, so I don't want to add a background color to the search field. I want the background view to have a different frame than the search field. Let me construct it as a UI view and then add it just before the search field. Add subview, search background view. We'll also need to assign a frame, so let's do it within the view the layout subview. X to be 20, Y to be 100, width to be view.bounce.width minus 40, height to be, I guess 60 will work better. And let's also change this because I feel like it's a little bit too high. So let's change it to 110, make this a height of 40, and then make this starts at 30 and see how this looks. Right, everything now has a white background, so we don't see anything. Let's give the view a background color of a light gray. White to be 0.9, alpha to be 1. And then the search background to have a background color of white. Now you see that the search bar appears at the top of everything else. So nature will show nature's picture. Next up is just to animate this view. I will also would like to add a corner radius to the search background view to make it look a bit nicer. Equals 4. Let's do that. So to animate these two views, we have to observe the content offset of the collection view so that when the user is scrolling, we can update the frames of the background view and the search field according to the content offset. So let's set the collection view static to be our view controller as well. Extension view controller, and then UI scroll view. Delegate. To observe the content offset, we implement this scroll view scroll method so that we get a callback every time the scroll view scrolls. And then this, let's call layout search bar, which is a function that I'm going to write right now. So in this layout search bar function, let me just move all the layout logic for the search bar into here, and then also call this layout search bar within view the layout subviews. And in this layout search bar, we have to set the frame of these two views according to the content offset. So here is how I'm going to do it. First, I would write a new function called getProgress, which calculates the progress of the animation using the content offset, which will be a CG flow, a start value, which is another CG flow, and an end value, and will return a progress. This progress will simply be calculated as the percentage of completion from the start value to the end value. So it will be offset minus start divided by end minus start value. And let's get the progress within the layout search bar method. Get progress. The offset will be collectionView.contentOffset.y. The start value, since we have set the content inset's top value to be 300, so the initial content offset.y will be minus 300. And when the content offset reaches 0, we will want our animation to stop, so that the search background and the search field sticks to the top of the screen and stays stationary. Let's print out this progress value as we scroll the collection view so that you get an idea of what the value is. So initially, the progress value will be 0. And as I scroll down the collection view, you will see that the value slowly reaches to 1. And at the point where the first photo cell reaches the top, the value will be exactly 1. So when 1 is reached, we will make the search background view and the search field stationary at the top. We will need to write another method that uses the progress value and determine the current frame that we want to set to search background view and the search field. So it will be we give it 2 parameters. One is the starting frame and the other one is the end frame. And we calculate the current frame based on the progress that we give to it. So this function will return a cgdirect with xy width and height calculated from the progress. So it will be progress times end minus start plus start. And we have to do this for all of the 4 values here. So end.x, start.x, and start.x. Oh, sorry, it's min.x in the latest SDK. And we copy this for the next 4 value as well. And so this one is min y, and then width, height. And then we use this method to determine 1 frame for the search background view and another frame for the search field. So for the search background view, let's use the progress and assign a starting frame of what we had before and an end frame of 0, 0, width and height of 80. So this is basically what we want the search background view to be when the progress reaches 1. Sorry. For the search field, we will do the same thing. We use the progress, we assign the starting frame to be what we had before, and we assign the end frame to also be one at the top. So let's do 10, 30, root of on top of minus 20, and the height will stay the same. Let me show you what this will look like. So initially, the search field will be here. Let's actually type something in here so you will see it better. As I scroll the collection view, you will see that the frame of the search field and the search background view slowly reaches to the top. And at the point where the first cell reaches the top, the search field will also reach the top of the screen. But right now there's a problem. When I scroll over the top, the search field will basically move outside of the screen. This is pretty simple to fix. We just need to limit the progress to not go over the value of 1. Another thing you will notice is that if I pull down hard enough, you will see that the frame of the search field also becomes very small and it looks a bit off. So we might want to limit that as well. So let's do a let's assign another variable called plan progress to be max of 0 in progress and then minimum of 1 in progress. So this clamp progress basically will never go outside of 0 and 1. And we use that to set the frame of the search background view and the search field. And once we run this example, you will see that now the example looks pretty similar to what we had shown at the beginning of the example. There is a delightful touch that we can add to this example. When the user overscrolls the scroll view, right now the search bar stays stationary and it doesn't react to the overscrolling action. We can make the search field expanded a little bit so that it gives that bounce feeling that UI scroll view usually gives to the user. And it makes the search bar seems more responsive. Whenever the progress is less than 0, we know that the user is overscrolling the scroll view. So we can use a different calculation method to calculate the frames for the search bar. When the progress is less than 0, we use the starting frame for the search background view, but we add a little bit of the height to it. So we use the progress times a small value so that the height is expanding as we drag down on the scroll view. And we do the same thing for the search field. We use the starting frame, but for the search field, we don't need to expand it. We just need to modify its Y position a little bit. We also add progress times a small value, maybe 20. And you will see what this effect looks like. So now when the user overscrolls, you will see that the search field expands its height. It almost seems like the user is stretching the search field. And it's pretty nice to see every element on the screen reacting to the user's action. Alright, I guess that's it for today. Hope you liked the little tutorial that I show here. I will upload the cleaner version of this example to GitHub, and you can feel free to browse through. And please give CollectionKit a star if you haven't do so. Thank you very much for watching, and bye-bye.